All right, on behalf of the Sloan Foundation, the Russell Sage Foundation, and Princeton University, it's my pleasure to welcome you back to SICSS. In this next section of the content, if people in the room could please, the rabble-rousers could please calm down here. We're going to move on to the next in our series of topics on digital trace data. We're going to spend the next half hour to 45 minutes talking about application programming interfaces. So what is an application programming interface or an API? An API is kind of a tricky concept to wrap your head around, but we all use them kind of every day. You can think of an API as kind of a pipeline that allows us to make custom requests for different types of data that we might use to, say, integrate multiple databases on the internet to build apps or to make websites run, or increasingly to do things like analyze our data, as we'll talk about at the very end of this section. But you know, if you think of a large website, the chances that website has an API are very high. Why are they high? Well, somewhere around, I don't know, 6 or 7 years ago, we entered, you know, what many people call like the Web 2.0 environment. So as I mentioned earlier, in the first stage, it was kind of the wild, wild west. Everybody was grabbing data everywhere. Then, pretty abruptly, everybody started guarding their data. And that was because of some, you know, very unfortunate initial disclosures in the data. So for example, America Online, which used to be one of the premier providers of internet service, released for research purposes a list of web searches by a large group of individuals. So as you can imagine, this is potentially very sensitive data, and it wouldn't have been a problem were it not the case that many people Google themselves. So as soon as someone Googles themselves, especially repeatedly, you can then infer what they were searching, right? Which is a huge violation of privacy, in my opinion and in many people's opinions, and leaded many other Silicon Valleys to kind of stop sharing data with researchers, but also more broadly was kind of a harbinger of things to come, which is to say a kind of a massive shutdown on sharing on the internet. Then when Web 2.0 came around, you know, social sharing became such a linchpin of the internet. If your website couldn't be integrated with other websites and share data readily, then you were going to also face kind of dire consequences, right? So if you're Facebook and if you can't give people a tool to share New York Times articles or Spotify songs or whatever, you're also going to lose competition. You're going to lose your competition, right, to another social media platform or something like that. And so APIs, though not particularly new, are a technology that allow data to be transferred across sites. The tricky thing is, and the reason we need a new technology is not everybody should have access to all the data on all the sites. And so essentially what APIs do is regulate who gets access to what kind of information, how often they can access it, and in many cases kind of sets rules for what they, or tries to set rules for what they can do with it. So this, you know, super awesome infographic here gives some examples of what, you know, an API might do. It's this kind of yellow band that connects all of these different structures on the internet and allows information to flow between them. Although, as I'll say at the end, that what APIs can do now is actually going beyond just sending and transferring information. So APIs have kind of pretty spectacularly grown since around 2006. By January 2018, we were up close to 20,000, and I think now we've easily surpassed that measure. If you're curious, you can visit Programmable Web, which is a website that tries to track all the APIs in existence, or at least the public ones. Many APIs operate only within a company and are not public-facing APIs. And so there's this real explosion of this technology, and many of the most popular websites have an API. So if you go to this link here, and again, the slides are linked in the schedule on the Princeton web page for today, you can visit a directory of all of these APIs, some 20,000 and counting, and they're easily indexed by different types of fields. So if you're interested in health, there are health APIs. If you're interested in GPS data, there are GPS APIs. If you're interested in media data, there are, the New York Times, the Washington Post, most large media organizations will now have an API. They will vary quite a bit in what type of information they share it with you and how they share it with you and how much they'll share it with you. But it's a great way for the kind of pioneering young computational social scientists to try to get a sense of what data is out there. Because very often when students set out in social science, they look at the very well-formed data sets, the General Social Survey, the American National Election Study, the census, something like that, and try to find their research question. And what both Matt and I have been adamant about now for many years is like, why not build your own data? Like, why not create your own data set? It's easier than ever, and there's just this wealth of unfarmed data. Now, a lot of this data is not usable for social science purposes. Returning to our earlier discussion of ready-made versus custom-made data sets, these are all ready-made data sets, meaning they were created for a different purpose than social science research. I guess there are a few exceptions like bibliometric APIs, which are primarily designed to enable scientific research of science. But generally speaking, Facebook's API was not designed primarily with social scientists in mind. So maybe after this lecture, or maybe you've had a chance to check it out by now, go to this link and take a look at the really stunning number of APIs that are out there. So we're going to do an extended example with Twitter towards the middle and end of this lecture. And the reason for that is that Twitter is one of the most open sites on the internet. It is by definition primarily public, unless you have a private account. And it allows you to collect quite a bit of data about a range of different issues. But before we get into working with a relatively complex API like Twitter, we're going to try to take a baby step first, which is to use a Google API to geocode a term. So what we're going to do is take a chunk of text and try to return the latitude and longitude associated with that text. We're going to look at like the name of a city. And the way that we do that fundamentally when we're using APIs is to make an API call. And so here's kind of the anatomy of an API call. First, we have what's often referred to as the base URL or the base API URL. This one we're using today is called maps.googleapis.com. And this is one of over 100 APIs that Google maintains. So Google has various search APIs, various map APIs, various advertising APIs, a lot of APIs that do things that social scientists might not be interested in, but it also has a translate API. It also has a variety of tools that will be of interest to social scientists, and certainly the Maps API can be useful, particularly if you're interested in geography or GPS, or even producing lists of named entities for your research, such as businesses or other organizations. So every API call begins with some type of base URL, and then we request some particular field or data from that API. So here we're looking within the maps field and the API field and the geocode field. Why are they called maps and API? Well, that was just some software engineers' convention for naming at Google, so don't make too much about what that exactly means. Indeed, one of the main challenges in working with APIs is learning how to decipher the API documentation, which is typically a large website that describes what types of names are given to what types of data and how you're supposed to construct your calls to get that data. But in the case of Google, that's what this looks like here. The data we want, which is we want to encode the latitude and longitude of Duke University, we're using that with these fields, geocode, API, and maps, or these folders. And next, we're making a request for JSON data. That's the type of data that is very often returned by APIs. Sometimes we might get XML data as well, but JSON is very common. And finally, we have our query, the thing that we want to subset from the very large database of known latitude and longitude in the entire world, which is the term Duke. we would get a different result searching for Duke in, say, the United Kingdom than we might in North Carolina, where Duke University is in the US, because Google will probably use a bounding box for searches around our kind of local geographic area from where we make the API call, but let's forget about that for a moment. Basically, what we're doing when we're constructing API calls is looking for generic structures of a URL and then switching out one term. So suppose we wanted to encode a list of dozens of known universities. And we had a long list in some kind of data table or some type of data frame. And we wanted to just simply switch out Duke and then Princeton and then University of Illinois and then University of California and so on and so forth and get the latitude and longitude of each one. Well, what we'd do is we'd write some code, and each time through the code, we would switch out the name that gets entered. And then essentially what we're doing is scraping the JSON data from the browser. I mean, that's a little bit of a conceptual leap, but basically what we're doing is grabbing the data that results from the URL call in our browser. So if we put this string into our browser, we get something that looks like this. It may have changed recently as Google has been shifting its criterion for the amount of data that can be accessed and whether one needs specific credentials or codes to access the data. But it should look something like this if we've constructed our API call properly. And here what we're seeing is all the data that Google knows, or the Google Maps API knows about the term Duke. And somewhere hidden deep within here, which you can't really see, is the latitude and longitude of Duke University. We're also getting some data on the state that it's in, the county that it's in, the country that it's in, and so on and so forth. I think the census tract that it's in. And so then the next step is to parse through this, just like we parsed through the HTML. But the nice thing about parsing JSON is that it has a reliable and consistent structure. So it's typically a list, so there might be character vectors or numeric vectors or even data frames contained within the JSON. But we can use the atomic operator, the $sign in R, to index the JSON object that we create to extract those fields. I'm not going to say much more about how to do that because I want you to get the intuition about how an API works from this part of the lecture, but I don't want you to yet write your own custom API calls like I've done here. Why? The answer is because there are many fine packages in R or modules in Python that will do this for you. So they construct all the complicated syntax, they sift through the massive and Byzantine API documentation that you need to learn how to use in order to construct API calls, and let you quickly and efficiently do the things you need to do to get the data from the web page. But I want you to know how, like, the fundamentals of how an API works in case you, say, want to use an API that doesn't yet have an R package or a Python module that allows you to neatly construct the calls, or if you wind up building an API yourself or many other features, it's kind of just good to know what's actually going on underneath the hood. But for now, we're not going to spend time parsing the JSON because we're going to use other tools to do that. So if we wanted to design our own API calls, right, we just have to switch out the field, the query. Maybe we want different types of data for different types of queries, and we would fold all that into some type of loop and repeatedly request data in an iterative fashion. Okay, so the first thing you need to know about working with most APIs is that most of them require some type of credential. This is some type of character string that announces you, the developer. You need to think of yourself as a developer if you're going to think about using APIs, because that's most of the people using APIs are software developers. You have an identity. Your identity and your credentials, this long string of text and sometimes numbers, allows you access to certain types of data on the platform. It prevents you, at the same time, from accessing other people's data that you're not supposed to have. And it also determines and tracks how much data you request and in what time frames. And these are all really important things for the owner of the API, right? If I really want to know what's going on Matt's Facebook page, but he hasn't responded to my friend request yet, jerk, then I need to I can't just go in and put his name into Facebook and scrape his data, right? Until he finally accepts my friend request, I can't see his data. And that's a good thing, right? There's a purpose for that. Likewise, if I sent a request for all the data from Elizabeth Warren's Facebook page every single second of every single day, eventually it would overload or overburden Facebook servers, and they'd have to deal with my request instead of dealing with the request to load that page from any number of people who also want to see it. So the owner of a web page, of an API also needs to limit or rate limit the amount and number of requests and the frequency within which they can occur. So the first thing we're going to grapple with is credentials. That's the codes we need to define ourselves as one who has the right to use an API. And then rate limiting, which is the process of knowing how many calls we can make within a predefined period. So the process of credentialing, or getting these codes that allow you to access the API, varies quite a lot across sites. We're going to look at a quick example here with Facebook. So if you navigate to this link here, this is something called the Graph API Explorer. So Facebook's API is called the Graph API. And basically what this is a sandbox, meaning a web-based environment that allows you to play with the API, try out some API calls without really, in a very small scale and without really messing anything up too bad. So basically what you'll see if you go here, sorry, I don't have it open, but basically you'll see here is something very similar to the Google page that we saw earlier. You'll see some search bars that allow you to put in fields like a user's name or a user's birthday or an organization. And if you experiment with that, you'll pretty quickly see that you are not allowed to get access to most of the data on Facebook. You can, with this Graph API Explorer, explore your data. You could pull, your birthday from that data if you've shared that with Facebook. But you, again, couldn't get anybody else's data. Why not? Because the temporary credential, which you've been given to use this page, is generated by this tool, and it only allows you to see the data of you, the logged in user, or any content on Facebook, which is by default public, and at that, only a small amount of that data. So really, this is not very useful for social science right now. Again, generally speaking, Facebook's API has become increasingly restrictive to the point where, unless you get credentials to access someone's data, you're not going to generate a lot of Facebook data unless you're collaborating with Facebook. We'll talk a little bit later about how you could build an app that could allow you to get credentials that allow you and request a user's permission to access their data, which then can allow you to make a request, a legitimate request. But that in so doing, as you're requesting that authorization, you are actually changing your credentials as the owner of an app to access that data. So basically, credentials, broadly speaking, refer to your identity before the API that is defined by your level of access to the data. You, in the case of Facebook, should only be able to see your stuff, your friend's stuff maybe, but nobody else's, right? Other APIs will be very different. Some APIs are fully public. So you can, for example, go and get data, whatever kind of data you want from them, and you don't need any credentials. Some are public, but still require credentials to make sure you don't make too many requests within a short amount of time. Other APIs require you to pay. So there may be like a privileged level of access to get better data or more data fields, and you might have to pay a monthly subscription, which is then actually changing the meaning of your credentials before the API and allowing you to get more data. So the key concept here, though, is that these credentials are something that's very important in the process of making API calls. Typically, the first API call you have to make somehow authenticates yourself before the API and announces who you are and allows the API to determine what type of data you're supposed to get access to. So that's credentials. The second kind of thorny challenge with working with APIs is what I mentioned earlier, rate limiting. So this is the threshold at which the API you are trying to extract data from will stop you from getting data within a certain time frame. So this is the case where if you make millions of requests for information from a single page in a short period of time, instead of getting the information maybe after your 100th request, you might get an error message that says something about an SSL error or an OAuth error. This is the API telling you that you no longer have approval to get that data. Typically, the process works in as follows. So you make too many calls, you get rate limited. That generates, hopefully, some type of error message, though not always, that you might see in your browser if you were putting URLs in the browser, or that you might see in your R console if you're repeatedly making API calls, or in your Jupyter Notebook, or whatever you're using. And so once you see that, you can pretty reasonably conclude you've been rate limiting. The next thing you will surely want to know is how much data can I get within what type of time frame. We would all love every API to list that on their webpage, on the API documentation, right? Some do, as we'll see. Twitter allows one to make a call that asks how many calls I can make within a certain type of period for certain types of data, but many APIs do not. Why don't they? Well, if you do the thought experiment, if I was some kind of nefarious actor and wanted to, say, disrupt Facebook, if I knew exactly when they were going to rate limit me, I could launch many virtual machines and push them all to the very limit of rate limiting and do a kind of simultaneous swarm attack and thereby create a lot of problems, right? So if they're announced publicly, it's a double-edged sword. On the one hand, as researchers, we like that because we know what the rules are and we can stay within them. On the other hand, as a company, that creates potentially a vulnerability. And so very often what we see is a kind of cat and mouse game with rate limiting. So you make some calls, you try to guess what the rate limits are, but the rate limits can be defined by features that you're not seeing. So you may have a certain amount of requests you're allowed to make every 15 minutes. You may have a certain amount of requests you're allowed to make in your lifetime. And when you get rate limited, you might not know which of these rate limits you violated. So that's a bit frustrating. We'll see with Twitter, there's some good tools to use to help you figure that out. But if you're, for example, working with a high volume of Facebook data, you might run into this issue, and it can be difficult to figure out exactly why you're being rate limited. Okay, so everybody have the big picture of credentialing and rate limiting. Are there any questions, either in the room or on the live stream, about what an API is, what credentials are, what rate limiting is, or what these URLs are that we're constructing to produce data? Yeah, Victoria.
Just if we were following along with the maps, the Google Maps
Yeah.
API that you gave us, what would we have to put that into? The read HTML?
Oh, no, you could just literally put that in your browser. Like just go to Chrome and put it. You could put it into read HTML if you're using RVest, which we used in the previous step. But I usually, for illustrative purposes, would just put it into Chrome and as I recall, I think sometimes people, I think Google, as I mentioned earlier, may have just changed its API so that you may need to have credentials. Is everybody getting an error message? Teachable moment. Okay, so this is like, APIs are dynamic things, right? Every year of the Summer Institutes, I've had to rebuild all of these slides, much to my chagrin, because each company is changing what they do. So it used to be that Google would allow you to make a request for information without credentials. What I think we're seeing now, given that you guys are getting an error message, is that Google is now requiring credentials for any API request, even a single API request. But we can certainly look into that. Maybe someone in the Slack would be so kind to look into that and get to the bottom of it. I seem to remember that in the back of my mind somewhere, reading about that. But we need to do a little more detective work to figure out exactly why it didn't work. But thank you for bringing that up. Okay, other questions? Anything from the live stream?
There's a question, but I think it's better for the
Okay, all right. Okay, so now we get into some more fun stuff. We're going to obtain credentials to access Twitter's API and make a number of calls to collect data, network data, text-based data, which we might analyze tomorrow, and various other kinds of data from Twitter's API. We're also going to use the API to run bots that we'll talk about in the next section. But before we begin the process of developing credentials, let me just say a few words. first of all, we are, in the eyes of Twitter, announcing ourselves as people who want to use the API. So we're about to go through the application process to register as a developer. Maybe some of you are already registered as Twitter developers, but if you're not, if you go to apps.twitter.com, you'll have to have a Twitter account, and you'll have to have a Twitter account that has two-factor authentication that actually has been verified with a mobile phone. Why do you need to use the mobile phone? It is because this discourages the use of fake developer accounts in the eyes of Twitter. It didn't used to be that way, it is that way now. And so you can go to this website, begin the process of registering as a developer, and then we're going to begin the process of creating our first app. We need to create an app in order to get the credentials to make our API calls. The somewhat tricky thing is that we're actually not really going to build an app right now. We're simply trying to get credentials to get our feet wet with getting data. But conceptually, and again, remember, most of the people using APIs are actual software developers who are building apps. You're going to need to give your app some type of name. I recommend this process can take anywhere from 10 to 15 minutes for Twitter to review to, I've seen, as long as 2 weeks. So you may not get your credentials today. I can tell you that I would recommend specifying what you want to do with your credentials. You might, if this is the first time using the Twitter API, you might say taking a class on APIs and text analysis as part of the Summer Institutes in Computational Social Science. If we all use some kind of consistent language, it might not flag things on Twitter's end. But invariably, at least one student every year has a lot of trouble. And I can't tell you exactly why that might be. It might be that Twitter has some kind of flag for, some type of user behavior or something that I can't say because Twitter hasn't made that public to my knowledge. So if you go to apps.twitter.com, and if you need to create a Twitter account, you can. If you don't want to follow along, you're under absolutely no obligation to create a Twitter account or follow along. But if you do want to get the data and follow along, you will have to go through these steps. You'll have to apply for a developer account. You'll have to add account details. You'll see there's two types of accounts you can apply for. One is for personal use and one is for organization use. Our lab, the Polarization Lab, has an organization account. That allows you to allow multiple users to use one set of credentials. But for your purposes, you're going to want to choose the personal account. The organizational account has an additional layer of scrutiny that will delay getting credentials. Then you'll have to answer some questions about your use case. You'll have to accept Twitter's terms of service. Each and every one of you will read every word of it and carefully digest its meaning, and then press accept. And then you'll get a response by email that announces Twitter's decision. And again, probably one or more of you will get denied. And this process I've been trying to figure out from both inside and outside Twitter, and I don't have a good set of answers to you for exactly how this process works on the other end. I can say, though, if you do get denied, usually there's like an appeal process, which they simply want more information about why you're requesting permission. I'm a little bit nervous that we're simultaneously making 300 accounts requests simultaneously from 11 different parts of the world. And so if those of you in other sites experience challenges, apologies for that. I don't know of a better way of solving this problem. Hopefully, at least one or more of you can get access, and then you can follow along with your neighbor, or if your site organizer has credentials, which many or probably all of them do, they might be able to showcase the techniques. And I'm going to be showing you what it would look like if your credentials were working. I'm going to give everybody a little bit more time to get through these screens. And I'm going to begin going through the process while we are doing the hardest part, which is while your application is under review. So if you've successfully completed the user registration account, you will have gotten here. You may get asked for your website. You can put in your personal website if you have one. In my experience, you can put in many different types of websites, like your university's website, and I think the main reason you get asked for this is because, again, most people using APIs are developing an app which actually has a location on the internet, which then specifies the terms of service of the app, the privacy policy of the app, and in many cases, the Twitter review team is probably visiting this website to ensure that your app is safe and has appropriate safeguards for user privacy and things like that. But in your case, if you're clear in your use case request that you are simply requesting access to begin learning how to use the Twitter API, I hope you will get approved. So, with apologies to everyone who's still waiting, and again, I assume most people are still waiting, you will eventually reach a screen that looks something like this. This is an app I built for my undergraduates to help them make API calls to study celebrities on Twitter, everybody's favorite topic. And basically, what you'll see once you've got an app that's approved is the name of the app up here. And then you'll see a variety of properties of your app. This one is not through the Polarization Lab. This is a personal account. And then you'll see here I've blocked out this field here, which is called the consumer key. Twitter, for reasons I don't fully understand, gives you 4 different types of credentials, whereas many APIs just give you 1 credential. And basically, you access those by going to this Keys and Access Tokens tab. And there you'll see these 4 different types of credentials. And you need to cut and paste those credentials into your R console or your Jupyter Notebook or whatever you're using in order to make your first API call to authenticate yourself as someone who wants to use Twitter's API. One other thing you'll need to do, you'll see here there's a field called callback URL, and this URL here is the IP address of your computer or your browser. And what that allows you to do is authenticate via your web browser as someone who is using the app. So you've built this app, then you as the logged in Twitter user then have to click accept, I agree to share my information with the name of my app. Kind of silly, right? But we're going to write some R code that will then open your browser and produce a authentication dialog where you have to accept that the app is trying to use your data. And then once you do that, then you'll get a kind of a success message in your browser in like small Courier New font. And then you will be allowed to begin making requests for data. So we'll walk through those steps, but I just wanted to give you a sense of where we're going. So you will need to, in your app, change the callback URL to this URL. And the reason you need to specify this one again is so that your app will open in your browser. You can imagine if you had built some kind of sophisticated app for the New York Times or something like that, it would have its own IP address somewhere else, and that's essentially the address where you're telling Twitter, this is where I want you to talk to me at. And so for the browser-based authentication that we're going to do, we're going to want to use our browser. This is how we get there. Okay, so here's the page that I mentioned that contains all of your credentials, your consumer key or API key, your consumer secret, and your API secret. And your codes will appear here. They will be long strings. Here's your access token and your access token secret. And these are the 4 codes which together allow you to authenticate with Twitter. Over the years, Twitter has changed as to which combinations of credentials it requires to allow you to authenticate. The safest way is to put all 4 of them into your code, I found, though sometimes you can get away with just putting 2 in. As you cut and paste these, you have to be very careful not to either cut off the very end of the string, which is a very long string of letters or numbers, or accidentally add spaces to your strings. One of the main challenges people have in authenticating with Twitter is often simply that they are unable to, they inaccurately define the string that we're going to use, the string object or character object in R that we're going to use to pass to an R package we're about to use to authenticate with Twitter. So just take great care as you're cutting and pasting. For now, if you've got access, you can cut and paste them into your RStudio console, or you can come back to this page. And again, I assume many of you are still waiting for your developer account to go through. And if this is the case, you can simply follow along and maybe start up your calls in, say, 5 or 10 minutes, hopefully, or hopefully within the next few hours. There are a lot of different packages for using APIs, as I mentioned. There's a really nice one for Twitter called rtweet. There was an earlier variant called twitr, written by some of Kevin's colleagues at NYU. This one is written by Michael Kearney. There's a pretty good community of people who provide support for it, meaning when something breaks, people come together and fix it. And so, you know, as is true with any open source software, you know, it's buyer beware, right? There's no consumer advocacy or, you know, really sophisticated user support. If you have issues, the best resources are probably the GitHub repository for that package, where you could track issues. So a good old-fashioned Google search for the error message you might get in your R console could direct you to a GitHub issues page where people are discussing how to solve a problem or what needs to be fixed in the package, or provide a temporary fix for you, hopefully. Or sometimes Stack Overflow, the site which many of us use to discuss solutions to coding challenges in many different languages, but including R and certainly Python. And there, if you've never used Stack Overflow before, the convention is to ask a question with some sample data or use case. And the reason that you are asking a question with something that another person can reproduce on their computer is to make sure that you are not having some fundamental reading in data error or some kind of unique property of your data that is producing an error message that other people can't help you fix because they can't see the error message on their machine. So the convention, when you ask a question on Stack Overflow, lest you inspire the ire of many anonymous software developers, is to share some type of snippet of your data or some sample data and then reproduce the issue that you want. Say you want to restructure data in one way, you might say, my data looks like this and I want it to look like this. Then users will provide solutions to your problems, and those solutions will get upvoted or downvoted, and the best quote-unquote answers will rise to the top. The ones that get upvoted the most will appear immediately beneath the Stack Overflow question, and those often, but not always, provide some of the best solutions to your problem. So if you're new to Stack Overflow, maybe read it a while before you start asking questions. But once you're on there and learn how to navigate it, between GitHub and Stack Overflow, you'll find many of the best answers to any and all coding questions. So fortunately, as I mentioned, rtweet is a package that is relatively stable, meaning like it doesn't break too often, and it is pretty broadly used, meaning there's a lot of people who care about keeping it working, myself included. And so we can install our tweet package like this, install our packages. We need to load the library. I'm missing that library function. We need to write library rtweet before we can begin using the package after we install it. But the first thing we can do is we can take the codes that we got from that developer page where we created our app. So we have the app name, the consumer key, the consumer secret, the access token, and the access token secret. Why is it called an access token secret? Why is it called a consumer key? On Facebook, it's called an authentication token. Again, these are the somewhat arbitrary decisions of some software developer somewhere deep inside a company. So don't worry too much about what these words actually mean. They're simply codes that you are using to establish your identity vis-a-vis the API. So you would be cutting and pasting your credentials, these codes that, again, you get from the other page, in between double quotes. That's a string or character object, which we define using these different objects here. We define as these objects here. And now we're going to begin using functions within rtweet that are going to stitch together very long API calls, very long URLs that include the names of the fields that we want. Say we might want, to see Matt's Twitter timeline or something like that. But also our credentials. And the order in which credentials appear and the characters that appear before and after our credentials define whether or not you can authenticate. And this is the painstaking work of navigating the API documentation, which can often involve looking at sample calls. But it can be very frustrating if you, for example, leave out one and sign or one plus sign or one underscore, your API call might not work. And so we love packages that do all this work for us because we don't have to suffer through all the API documentation in order to figure out exactly what's working. Just as earlier I was saying, if you find screen scraping frustrating, it's screen scraping, not you. Very often, it's the API, not you, that's causing an issue. And it's about endurance as a coder. It's about, so looking at your resources, communities like this, our Slack channel. Has anyone ever had this error message with, our tweet package? That's a great, phenomenal resource. And remember that after the Summer Institute, we continue to maintain a Facebook page, we continue to connect on Twitter, and we're hoping this year to keep the Slack going, though last year we exhausted the messages after the first week. So we'll see, we'll look into doing that. But bottom line is there's a community around you, remember that, and in the absence of a direct contact who might know, like someone at this institute, you've got Stack Overflow, you've got GitHub. Okay. So this is what it looks like when we make our first API call, which is announcing our identity to Twitter, that is allowing us to make subsequent calls for all types of information we might want. First, we're going to load the rtweet package, like I mentioned earlier, with our library function. Then one of the workhorse functions within the rtweet package is this create_token function. There, we're passing all of the objects we created in this previous step, the app name, consumer key, and so on, which we've now defined as these R objects, in this function here. So what this is doing is taking all our unique codes and stitching them together into a really long URL, then ingesting the JSON, parsing the JSON, and returning, or actually in this case, it's making a call to load our web browser via that callback URL that I was talking about earlier, and then you'd see that authentication dialog in your browser that asks you to authorize your app to collect data. If we don't take this crucial step of authenticating, we won't be able to do anything else. Every API call we make will result in some kind of authentication error. You might see the term OAuth or SSL. That's indicating you have not yet successfully authenticated. Okay, but if you have, and now that you've gone through the process of credentialing and you've built your app, you've got your developer account, and again, all APIs will vary in how this credentialing process works and how authentication works. But in Twitter, we're now in, and we can now begin to make calls for data. So on the day that I made these slides, North Korea was in the news, and Korea, and so I decided to make a few examples around Korea. We're going to use the search_tweets function to search for mentions of the hashtag Korea, and we are searching for 3,000 tweets. And we've decided not to include retweets in this call. So when we make this call, by default, we would get people who are repeating that. And this simply shuts that off so that we get unique tweets about the Korea hashtag on the day in which I made these slides. And from that, we're creating a new object called Korea tweets. Our tweet is not only handling all our authentication for us, it's creating the long URL, it's ingesting the JSON, and then it's parsing the JSON into a beautiful square or rectangular data frame that we can then do whatever we want with. And that's really handy. So if we look at the tweets, we have a data frame now. We're browsing the column names using the names function of all of the different fields that we get from the Twitter API for this type of call. We get the ID of the message, the user's ID, the text of the message, a bunch of fields that help us determine whether someone's replying to someone, retweeting someone, and so on and so forth. Yeah, we've got a question.
I just want to know if anybody else is getting this error in create token. No?
That's a very common error message. I suspect it has something to do with your credentials or the way they were entered. If one of the TAs could check out Victoria's, do you guys mind?
Was there comment in the Slack?
Yeah.
Oh, you got it. Okay. And is that shared in the main Institute channel or in the Princeton channel? I just want to make sure. General. Great. Okay, great. So great. Okay, so that's anybody else having issues so far? Okay. Usually we get issues because, again, APIs are living creatures that are changing and constantly frustrating us. You'll notice a lot of different fields here. We've got a language field. We've got a coordinates field. That's going to give us the latitude and longitude of the user who produced that tweet, provided that, and this is important, that user has agreed to share their location with Twitter. By my last analysis, about 1 in 100 Twitter users does that. And so that's a very relatively small population of people. However, many people are excited about using a variety of NLP tools in order to increase the rate with which we can geocode tweets. How reliable those are is a matter of some debate, but we can talk a little bit about that in a minute. And here you're seeing a lot of different other fields. The screen name, that's the Twitter handle. Once again, we have to live with the somewhat ad hoc or idiosyncratic decisions of the developer in naming all these fields. So why they used screen name and not handle, I don't know. In Twitter speak, if we're talking about someone's followers, we say followers, but if we're talking about the people that user follows, we talk about friends. These are just conventions that were made inside Twitter some time ago that we now just have to accept as the way that data is structured. But again, different APIs will have different names for different types of data. So if you've got in now, maybe you've got this data frame open, you're able to browse around a little bit, see what Twitter data looks like. Here's what the text of the first 5 or 6 tweets look like from the data on the day I collected it, which I think was last year. And we could browse through a lot of this text in many different ways, and tomorrow we'll be analyzing this using automated text analysis. The rtweet package has a number of built-in functions that do some handy things, like this function, tsplot, stands for time series plot. That is going to allow us to use ggplot, the popular visualization software in R, to produce this type of graph, which shows the frequency of tweets about the Korea hashtag for the past day. You'll note that we are getting, we're only getting the last day of tweets. One thing that's very important for you to know about Twitter data is that if you want to get retrospective data going back a long period, you're typically limited to the last 24, 48, 72 hours, depending on your process. Oh boy. Cool, folks, let's get started. We're now very behind and we have a lot more content to cover. Welcome back to those of you who are interrupted by the fire alarm here at Princeton. They're very precautious, these Princetonians, and we are back online. We were talking about making our first calls to the rtweet package in order to plot the frequency of tweets about the hashtag Korea over a 48-hour period. And I was just making an important point, which is that if you wish to get retrospective data from Twitter going back more than a day or a few days, you have somewhat imperfect options. One option is to buy the data from Twitter itself, from a company that it bought, which is called GNIP. That can be extremely expensive. When last I checked, I haven't looked in a while. Or you can identify a different data collection strategy, which focuses, instead of kind of streaming content, stuff that might appear in a random sample of tweets, like we've been using here to identify these hashtags, or probably random sample of tweets. We actually don't know if the generation process is random, but that's another issue. We can also use the user as the point of sampling. If we have a list of known users, then we can collect for each user's approximately the last 3,200 tweets of that user. And from that, we can then begin to populate what you might call time series data. But if your goal is to get all the data on Twitter for one hashtag or set of terms, even Twitter itself might not have that data, depending on the scale of your request and the difficult nature of sampling from the very large data sets that are necessary to create that data. So for the most part, most people using Twitter are either prospectively collecting data from Twitter, meaning each day they write some code that looks for some terms that they care about and then populating a database. That data is being drawn from a small microsample of all Twitter, so you're even then not insured of getting all the data. Or people are starting out with a list of Twitter users who they care to follow. And you can imagine either having a list, we're going to work with data from US senators, but you could also imagine combining something like respondent-driven sampling to use a given seed set of users, find all the people they follow, and then create some type of population that you care about. However you were to do it, you would then be finding users and collecting their retrospective tweets. You cannot get retrospective network data, meaning if you would like to know whether Matt followed Duncan Watts 2 weeks ago, you can't know that. You can know whether Matt is following Duncan Watts now, but not 2 weeks ago. So if you wanted that type of dynamic social network data, you would need to collect it prospectively each day. Okay, so with those caveats in mind, we can, and with the earlier caveat about the relatively low frequency of Twitter users who share their geolocation, we can use tools in our tweet, which I'm visualizing, which I'm illustrating here, that can plot the latitude and longitude of each tweet in about Korea, including 2 people who are apparently on the Great Lakes or on a boat. Why they were tweeting about Korea, I cannot tell you. But these are, I'm just demoing some of the functionality of the RTweet package. I'm going to go a little bit quicker than I'd like for the next few slides, only because I really want to get to the discussion of apps and bots. Let's say we have an individual user. As I just mentioned, we want to collect tweets by that users. We can use the get_timelines function from the RTweet package to do that. This is what that looks like. We're here searching for Bernie Sanders tweets. We're getting 5 tweets from Bernie Sanders' timeline. The timeline is his list of tweets. And we're visualizing in this next slide those 5 tweets. We can also get general information from the profile of a given user using the lookup users function. This will give us things like the biography, the about me section of a user's Twitter page, maybe their location, the number of followers they have, the number of tweets they've produced, the number of tweets they've favorited or liked, and so on and so forth. And so here we see that our tweet has nicely created a data frame for us called Sanders' Twitter profile. And from there, we have different fields that we could index. Here, we're looking at the description. Here, we're looking at Sanders' location, the number of followers, and so on. We can also make calls to get the favorites of any given user. So here, we're asking for the last 5 favorited tweets by Bernie Sanders. And then we've created a data frame called Sanders Favorites. And we are using the text frame of that. We're visualizing the text frame from that data frame here. And these are, at the time I created these slides, the last 5 tweets by Bernie Sanders. I want to point out this funny looking text right here, which we're going to learn tomorrow is the way that our tweet has decided to represent an emoji in our tweets. And that's going to create some headaches for us tomorrow, as I'll describe when I get into text analysis. Many of you are interested in social network analysis. I mentioned one of the great features of digital trace data is that they capture social relationships. And Twitter, perhaps more than any other public resource, allows us to collect massive amounts of network data, which we can do all sorts of interesting things with. So here's the code to extract the names of the people who follow Bernie Sanders. We've created an object called Sanders Follows. We can then browse that. We can also get the friends of Bernie Sanders, meaning the names of the people who Bernie Sanders follows, using the get_friends function. I mentioned earlier that many APIs do not tell you what the rate limits are. Twitter is an exception. Twitter has a useful API call that can be made to obtain your personal rate limits for different types of requests. And Twitter tells you exactly how many requests you can make within a certain time frame for different types of data. So you're allowed to get some types of data more often than others. If you run this function, rate_limit, it will produce a data frame that will allow you to see what your current rate limits are. So for example, these are different types of requests you can make from the Twitter API. You could ask for, if you knew about a Twitter list, a list of users who have been aggregated by another user for some purpose, and you wanted to get the names of those users, you can get 900 of those every 15 minutes. But on the other hand, if you wanted to know how many people are subscribing to that list, you can only get the names of 15 people every 15 minutes. And these are dynamic fields that will change as you make requests. and may change according to your lifetime behavior. And also, importantly, you should know that this rate limit request is also rate limited. So meaning if you were to make this call every single time you pass through a loop, you would probably unintentionally trigger rate limiting. So you can either write a function that looks up your rate limits periodically and then pauses your code using something like the sys.sleep function in R to wait and collect the appropriate amount of data within the appropriate amount of time. Or you can just generically kind of identify what type of data you're looking for, like maybe timelines is a common thing. We just got Bernie Sanders' timeline, and we might want to know how many tweets we can collect in a certain time frame, and then we may simply pause for 1 second at the end of our loop, and knowing that that will roughly yield near the appropriate number of API calls. There are a number of other handy functions. This one gets trends for particular locations. So what's trending in New York, you can use that. We see all this junk. And rtweet, this is one of my favorites, can also post a tweet via your account. So however you're authenticated, if you were to run this code, this message, I love APIs, would appear in the Twitter timeline of the user who authenticated the app. So if you run this code and you're logged in as you, this will tweet as you to write I love APIs. And as I've noted up here, this is a useful function if you are building a bot. In my own work with bots, we've had to write our own custom code, but if you have a fairly primitive bot, this may be fine to get you what you need. So obviously, as we did with screen scraping, we very often want to iterate across a large population of hashtags or users or network structures, and we simply do that by wrapping all our API calls that we're making via the rtweet package within a loop. So here, for example, we're reading in a list of elected officials that I've got posted on my GitHub, and we're using the read CSV function to create a data frame called elected officials. This has the name of elected officials and their screen name or Twitter handle. One thing you should know about Twitter is that Twitter users can change their Twitter handle, but not their user ID. So if you are following people over time, you should use their user ID and not their Twitter handle, because people do occasionally change their Twitter handle. So one of the other fields you can see in the databases you produce through rtweet will be a user ID field, and that can be useful for finding making sure you've got the right person, especially if you're in the business of linking data across platforms. Another thing to tell you is that each individual tweet has its own ID. It's called a status ID. And I mentioned earlier that it's hard to get historical data on Twitter, but it's possible, given a list of status IDs, to do what's known as hydrating tweets, meaning going back and populating your database with other mentions or interactions of that tweet, or a list of other objects of interest that you might want to scrape. So there are a variety of packages, especially in Python, but also in R, that would allow you to hydrate tweets in that manner. But again, very often we're working from a known population. Here we're looking at elected officials. And what we're going to do in our code is simply go through each user and put in their screen name. Again, probably it would be better to put in their user ID, but for now we're using their screen name because I think it's just more recognizable to people. We're creating a bin to put the data in that we're creating each time through. This is a blank data frame. That's what we're doing here. And then we're saying for each row of our elected officials data frame, so if you're new to loops, you'll need to know that this is an abstract variable, which is going to assume a different value between this number and this number here. This code, if I were to run it, would produce the number 457, I believe. We need that abstraction so that we can handle data frames of different lengths. But here what we're doing is we're going to change the value of I 457 times for each value between 1 and 457. When we do that, in this line of code, we change the screen name of the elected official that's passed to the getTimeline function, generating a unique database of tweets for that user. Next, we are binding each row of the individual Twitter user's data into our pre-existing data frame. So the first time through the loop, we're actually putting in the first row of tweets. The second time, we're adding and getting it bigger and bigger and bigger. We're pausing here to avoid rate limiting in a relatively hackish manner using this sys.sleep function. We could have gotten fancier with the rate limit function, but we're keeping things simple right now. And lastly, we've printed I at the end of our loop. This is useful if you're new in writing loops. If your code breaks, for example, let's say you've been rate limited, you might like to know when you were rate limited. And if you were rate limited after your 200th call, you'd know that you made too many calls when you reached 200 within the time frame within which your code ran. And you could also write code to tell you when your code started and ended if you wanted to get fancy about it. Or it may be that you have a blank row in your data frame, and when you pass that to the getTimelines function, you got an error, and then you want to know where that is so that you can go and clean up that line of data, or understand why it was blank, even better. Okay. So the good news is, even though it can be frustrating to navigate the API documentation and to construct your own API calls, there are many, many R packages now and Python modules that will allow you to create API calls without the tedium of sifting through the R API documentation. So we've got our Google Maps, our Facebook, which now doesn't do much but used to do a lot, and our OpenSci, which is a nice collection of open science resources in the R community that has some nice lists of R packages that work with various APIs. Our OpenGov. OpenGov is another large API for political research and legislative research. Our Times, which queries the New York Times API. WDI, which queries the World Bank's API, and on and on and on and on. And you'll notice if you've been using and installing packages from CRAN, you may also wish to know that many of the most interesting packages that are new are hosted only on GitHub and have to go through a process of vetting and approval in order to make it onto CRAN. So some of the newest and most adapted stuff might be on GitHub, and it might not yet have gone through the process of review on CRAN, or the author of the package may simply decide just to keep it on GitHub instead of going through the review process, which can be a little arduous. Okay. There are also, finally, APIs that can do your analysis for you. So far in this lecture, we focused on APIs doing things like collecting data, transferring data, but APIs can do analysis on your data. So there's visualization APIs like Plotly. There's image recognition APIs like the Google Image API. So last year, one of the Summer Institute projects passed tweets by elected officials through the Google Image API in order to look at the visual space of politics. There's optical character recognition APIs. There's APIs that run neural nets for you. There's APIs that do all manner of things, and we don't have time to cover them. But just so you know, if you don't know already, APIs do a lot of other things apart from just transfer data. Challenges of working with APIs include the documentation I've already mentioned, the process of credentialing, figuring out rate limiting, and of course just the general frustration that not everything that you might want in a database is available via the API. But when we compare it to screen scraping and the tedium of going through and finding the XPath or the CSS selector, and knowing that there are even better packages that parse the data and produce it in a format that's easy for us to analyze, usually I think most people will find that APIs are a superior alternative for social science research. And I started out with a list of from Programmable Web that describes some of the kind of first census of APIs. Here are some other resources that I've collected over the years that are some packages and APIs that I think will be of interest to social scientists. And I want to focus your attention on this last one here, which is a crowdsourced list of APIs that participants in the Summer Institutes over the last 3 years have added to, which is a list of APIs that people think may be of interest to social science research. So if you know of APIs that aren't on here, please add them. If you're looking for some new data sources, please check this out.